Assalamualaikum everyone, I am Nashrullah Ibrahim from TSP15. I am here at library want to test people knowledge about magnetism. So here we go. Hello and Assalamualaikum. So, sorry for the video and can I interview you a bit?
Yes,
Okay, first of all, what is your name?
my name is Putera Adam.
Okay, Putera Adam. First question is, what is magnetism?
Magnetism is a fascinating natural phenomenon where certain materials exert an attractive or repulsive force on other materials. This force most commonly associated with iron and ferromagnetic materials.
Wow, that is a great point. So we proceed to the next question. What are the applications of magnetism in daily life?
So, magnets are used in various applications such as electric motors, refrigerator door seals, and magnetic resonance imaging (MRI) machines in healthcare, showcasing the importance, showcasing the practical importance of understanding magnetic behavior like that of iron powder in a magnetic field.
Wow, what an interesting idea. That's all the interview. Thank you for spending your time with us. Therefore, magnetism is an important point to note here is that we cannot associate an individual magnetic pole. Every piece of magnetic, no matter how small, which contain a north pole and also contain a south pole. Thank you.
Assalamualaikum. Now we are going to do the magnetic field experiment.
Okay, the primary objective of this experiment is to observe how iron powder responds to the presence of magnetic field. By sprinkling the iron powder around the magnet, we can visualize the magnetic field lines and understand how the magnetic properties and force at play. So, the material is simple to do this experiment, which is we need two magnetic bar and then we need iron powder, the main materials, and the blank A4 paper. So, let's do the experiment. For the first procedure, we need to place the bar magnet under the A4 paper and then carefully sprinkle the iron powder evenly around the magnet. Ensure that the powder is fine enough to move freely and respond to the magnetic field without clumping together. After that, we can observe the pattern formed by the iron powder. The particles will align themselves along the magnetic field lines, creating a visible representation of the field.
When the iron powder is sprinkled around the magnet, each tiny particle becomes a mini magnetism due to the influence of the magnetic field. This phenomenon occurs because ferromagnetic materials such as iron have regions called magnetic domains. In the presence of an external magnetic field, these domains align with the field, resulting in the overall alignment of the iron powder along the field lines.
The pattern form is typically a series of curves radiating from the poles of the magnet. This curve represents the magnetic field lines which show the direction and strength of the magnetic field. Near the poles of the magnet, the field is strongest and the lines are closest together. As you move away from the poles, the field lines spread out, indicating a weaker field.
For the second procedure, we place two bulb magnets with same poles under the A4 paper. And then, carefully sprinkle the iron powder evenly around the magnet. Ensure that the powder is fine enough to move freely and respond to the magnetic field without clumping together. After that, we can observe the pattern formed by the iron powder.
Here, we can observe that magnetic field of the bar magnet with the same poles will repel each other.
For the third procedure, we place the two bar magnets with different poles under the A4 paper. And then, carefully sprinkle the iron powder evenly around the magnet. Ensure that the powder is fine enough to move freely and respond to the magnetic field without clumping together. Finally, we can observe the pattern formed by the iron powder.
From the third experiment, we can observe that magnetic field of the bar magnet with the opposite poles will attract each other.
This experiment clearly shows the principle of magnetism. By visualizing the magnetic field lines, it helps us understand the distribution and the strength of the magnetic field. Such experiments are educational and inspire curiosity about magnetic properties and their application in technology and nature.